Welcome back for the second part of lesson 4.3. We're going to dive in how to find binomial probabilities. So let's look at example 5. It says, it has been stated that about 41% of adult workers have a high school diploma, but do not pursue any further education. If 10 adult workers are randomly selected, find the probability that at most 6 of them have a high school diploma, but do not pursue any further education. How many adult workers do you expect to have a high school diploma, but do not pursue any further education? So let X be the number of workers who have a high school diploma, but do not pursue any further education. X can be anywhere from 0 to 10. The probability of success is 0.41, and the probability of failure is 1 minus 0.41 or 0.59. And we're going to describe our distribution as such. X can be described as binomial, N is 10 trials, and the probability of success is 0.41. So the probability at most, is this right here, less than or equal to 6. That means we're including 0, 1, 2, 3, 4, 5, and 6 because of the equal to. The answer is 0.9374 or 93.74% of them. Okay, there's 2 ways you can find this. If you have a TI-84 calculator, you're going to use these instructions here. You're going to go to second and distribution. So you're gonna hit second and then DIST right here, which is your vars button right here. And then you're going to go down to BINOM PDF, which is actually at the bottom. So if you arrow up, you will come to this one, PDF. So the PDF is if you want an exact value. But because we want a cumulative, we're including everything up through 6, we're going to use the CDF. Now, only use the TI-84 calculator if you have one, if you want to learn how to use it. Otherwise, follow my Desmos instructions. So if you're using the CDF, you're going to put in the number of trials is 10, the probability of success is 0.41, and we want to know up through 6. So we're going to go down and hit paste. And it looks something like this, and we get 0.9374. Okay, now Desmos is actually much easier because once you save the calculation in Desmos, you can go there and repeat these things over and over again. I'm going to show you my Desmos, but this is what it looks like. You're going to go and you're going to type in binomial dist with a left parentheses for n. And then comma, your probability of success. And you're going to click on cumulative if you want the cumulative. And then you're going to give the minimum up through what you want to have. Or if you want to do a greater than cumulative, you can also do that as your minimum up through the maximum. So that's the cool thing about Desmos is it does minimum, the less than cumulative, or the greater than cumulative very easily. And it shows you, it will color in the values that are included. So we wanted to include 0 through 6, and you can see those are all here in Desmos. So let's go there so I can show you where that's at. There is a link in our Canvas course that will show you that as well. But here is the Desmos for that. And I'm going to show you it's binomial dist, and then ours was 10, comma 0.41. Oops. There we go. Now, I'm going to turn this one off. Now, because I have 10, notice I've got 10 options here in my, down here in my outcomes in my graph. Now, if I want to find exactly a particular probability, I can click on them. Notice I'm clicking on, and let's say I want to know the probability that exactly 4 of my workers have a high school diploma but don't want to further their degrees. So that would be a 25.03%, 0.2503. Now you can also do a particular, if I were to copy this and then paste, and then at the end do dot, and then do PDF and put exactly what you want. So if I did the 4, it would give me that particular that I'm getting from the graph. So you don't have to go to the graph to get those. If you're looking for an exact one, you just do .pdf and then the one that you're looking for. Okay, so let's go back to the notes here. You can see the y-axis contains the probability of x, so 0 through 10. And we also asked at the very beginning of the question, how many adult workers do you expect to have a high school diploma but do not pursue any further education? That would be the mean. And the mean is the n times p. So this is the mean number. And the standard deviation is the square root of n times p times q. So 1.56. So on average, we would expect 4.1 of the workers out of 10 to only have a high school diploma, not pursuing any further education, give or take 1.56. So anywhere from about 2 to 5 workers or so of the 10. So let's look at one on our own here. Let's put this all together. It says, about 32% of students participate in a community volunteer program outside of school. If 30 students are selected at random, find the following. The probability that exactly 9 of them participate in a community volunteer program outside of school. So exactly 9 means that we're looking for a probability of exactly 9. And X is described as a binomial, N and P, so a binomial of 30 students, and probability of success was 0.32. So we're going to go to Desmos and put in 30.32, and then we're choosing exactly 9. So I'm going to make a new one here for us. So fusion of 30, 0.32, and then I'm going to do dot PDF because we want to know exactly 9 is what they said. So it looks like the likelihood of exactly 9 of them participating in a volunteer program is 0.15296, or approximately 15.3%. And let's just number, and that was 5. Okay, now the second part to this problem says the probability that at most 14 of them participate in a community service. Let's go back to show my paper so you can see. So it says the probability that at most 14 of them participate in a community volunteer program outside of school. So at most 14 is the probability of X being less than or equal to the 14. So we're using the same distribution, but now we're going to use the cumulative because we want to include 0, 1, 2, all the way through 14 because it says at most. So let's go back to Desmos so we can see how that's going to look. And so I'm going to copy this. And I'm just doing the basic one because I want to do the cumulative. The PDF is only one you want to find an exact. So I'm going to click on the cumulative and I want to go from 0 up to and through 14. And so my answer is 0.9695. That's a lot of students. Okay. So that's how I wrote that 0.9695. Let's look at the next example. It says in the 2013 Jerry's Terama Art Supplies catalog, there are 560 pages. 8 of the pages feature signature artists. Suppose we randomly sample 100 pages. Let X equal the number of pages that feature signature artists. Okay, what values can X take on? Well, we want to know only the ones that feature the signature artists, and there's only 8 of those, it said. So it can only be 0 through 8. What is the probability distribution? X can be described as B for binomial. We're sampling 100 pages, and we know only 8 out of the 560 are possible to be signature artists. Find the following probabilities. The probability that 2 pages feature signature artists is this. So this is a particular one, so that's why we did that PDF. So N is 100, 8 out of 560. Exactly 2 of those pages is 0.2466. The next question says, what is the probability that at most 6 pages feature signature artists? So that's at most 6 pages. So we're going to do 0 to 6 because it's including, it's a cumulative. What is the probability that more than 3 pages feature a signature artist? So in this case, more than 3 means that I want to go, actually, I want to go 4 and above. This should be 4 and above because it's more than 3. So I want to include 4 to 100. This will be corrected on your page. That'll get corrected. And that's going to be here in the Desmos. So we're going to do four. So we're going to do cumulative. And it is 100 is our sample size. And it's 8 out of 560 are actual signature ones. And we want to go 4 to the 100. Okay, and that's 0.05568 because it's strictly greater than 3. Let's just make a note for you in here. So I'm going to say, so start at 4. Okay, so that's 0.0557, 0.0557. Okay. The next one says, using the formulas, calculate the mean and the standard deviation. So on average, how many of them are signature artists? So of the 100, on average, we would expect to draw 1.4 of them to be signature artists. Standard deviation is the square root of n times p times q, and so that comes out to be 1.1867. So let's look at one on our own. You read through this. It says, according to a Gallup poll, 60% of American adults prefer saving over spending. Let X be the number of American adults out of a random sample of 50 who prefer saving to spending. So I'd like you to go through and try to answer questions A through C, and then I will put you back here in a moment. It says, what is the probability distribution for X? So X can be described as binomial, where n is 50, and the likelihood of choosing an adult who prefers saving over spending is 0.60. Use your calculator to find the following probabilities. The probability that 25 adults in the sample prefer saving over spending. So that would be probability of X equals 25. Let's write out what we're doing, what we want to find in symbols, and then we'll go do all of them together in Desmos at one time. The second one says the probability that at most 20 adults, so that's the probability of X less than or equal to 20, because we're going to include 20. The probability that more than 30 adults, so that would be the probability that X is greater than 30. Okay, so that means on that one, we're going to start at 31 because it's greater than 30. Using the formulas, then we're going to calculate the mean. Is n times p. We can calculate that one right now. So n is 50 times 0.6 means that 30, we would expect 30 of the 50 adults to prefer saving over spending. And the standard deviation is the square root of n times p times q. So that is the square root of n, which is 50 times 0.6 times q, which is 0.4. And so we can show you that here, the square root of n times 0.6.4, and the standard deviation is 3.46. So n times p times q, 3.46. So let's go into Desmos and find these three probabilities right here before we go on to the next example here. This is example. This is you try at 6. So we're finding exactly 6. I'm going to go up and just copy this one where it's an exactly, because then I can paste it and make sure I change my n to be 50. And my probability of success is 0.6. And I want to find exactly 25 of them. So there is exactly 25 of them, which is 0.04. So it's only 4% probability that only 25 of them. So it's pretty high, that 60% is pretty high of adults that prefer spending over saving, or saving over spending, sorry. Okay, and then I'm going to copy everything but the PDF to do the second one, because it's a cumulative. And it was at most 20, so that means that we're going to include 20. So 0 to 20. And that probability is 0.0034. I'll show you my paper before we're all done so you can see that. And then I'm going to copy that so we can have a separate one here. And this one is going to be cumulative, but this one was greater than more than 30. So that means we're going to start at 31 and go up through the 50. And that probability is 0.4465. I try to include 4 decimal places. So, and you know what, I'm just going to make a note here for you so you know what this is the probability. the probability of X being greater than 30. We don't include 30. We start at 31. There we go. I'm going to show you my paper so you can see how I wrote these on my paper too. So there are the probabilities there for that one. Okay. Example 7. The lifetime risk of developing pancreatic cancer is about 1 in 78. So 1 divided by 78 is 1 divided by 78 is 0.0128. That's why we have 1.28%. Suppose we randomly sample 200 people. Let X be the number of people who will develop pancreatic cancer. What is the probability distribution for X? It's binomial, where N is 200, and the probability of success, unfortunately, success here is that we're counting that they did develop pancreatic cancer is 0.0128. Using the formulas, calculate the mean and standard deviation. So mean, using our correct symbols, is N times P. So 200 times 0.0128. So about 2.56 of them out of 200. So it's a very small number. And then the standard deviation is equal to the square root of N times P times Q. So 200 times 0.0128. And I don't know what that is, 1 minus P right offhand. So I'm just going to say 1 minus 0.0128. That's, if you don't know what Q is, if you can't calculate it quickly, just type in 1 minus P. That's easier. So that's what I'm going to do. You'll see here on my calculator. I'm going to do 200. Times parentheses 0.0128, parentheses 1 minus 0.0128. And we get 1.589. So I'm going to round that to 1.59. Use your calculator to find the probability that at most 8 people develop pancreatic cancer. So the probability of X being less than or equal to 8. And then our other question is it more likely that 5 or 6 people will develop pancreatic cancer? Justify your answer numerically. So 5 or 6 means we want the probability of X equal to 5 plus the probability of X equal to 6. You could do cumulative to 5 and 6 if you wanted, but we want to, is it more likely that 5 or 6 people will develop pancreatic cancer? Oh, we want to compare them. I think we want to compare it to this, that less than 8. So we'll look at these here and kind of figure out, we'll just talk about those 2 scenarios. So let's go to Desmos to do that. Okay, so this one is, we have 200 people. I'm actually going to start a folder here so that it's easier to follow. I'm going to put that in that folder. And this is going to be the probability number 7. I'm just going to put it on here. This is the probability of X being less than or equal to 8. Okay. So this is 200 people, and the likelihood is 0.28. Okay, and so we're going from 0 to 8. 0, 8. So the probability is 0.9988 when rounded. So it's very likely that not more than 8 people are going to have developing pancreatic cancer. And then the next one was the probability of 5 or 6. So I'm going to do this with a PDF because I'm going to look at them exactly. So that PDF 5. And I'm also going to look at the 6. So exactly 5 of them having pancreatic cancer is much, 5 points more, about 4 points more than the 6. So 5 is 0.0707, and then the 6 is 0.02977, so 0.030. Looks like I'm here, so you can see. Hopefully you're getting the hang of this binomial distribution. Okay. So it says, during the 2013 regular NBA season, DeAndre Jordan of the LA Clippers had the highest field goal completion rate in the league. DeAndre scored with 61.3% of his shots. Suppose you choose a random sample of 80 shots made by DeAndre during the 2013 season. Let X be the number of shots that scored points. What is the probability distribution? So it's binomial. He either shot and scored or he shot and missed. So they said they were going to look at 80 shots, and his likelihood of scoring is 0.613. Using the formulas, calculate the mean and standard deviation. So the mean and the standard deviation is going to be 80 times 0.613. The standard deviation is going to be 80, square root of 80 times 0.613 times 1 minus 0.613. Let's quickly do those here. So we've got 80 times 0.613 is 49 about. So 80 times 0.613 parentheses 1 minus 0.613. And standard deviation is 4.36. And we'll just round it to about 49. Use your calculator to find the probability that DeAndre scored with 60 of these shots. Okay, so the probability that he made 60 of the shots. And then also find the probability that DeAndre scored with more than 60, more than 50. So the probability that X is greater than 50. So he scored 60, exactly 60, and then more than 50. So let's go ahead to Desmos here. So I'm going to do another folder. Number 7. And then this is the probability that X equals 660. do PDF one here. And I've got to change ours because this is and was 80, and his likelihood of making it is 0.613. And we want to know if you need exactly 60 of those 80 shots. So it looks like it was not likely he made exactly 60, because his likelihood is, the mean is only 49. So 0.0036. And then the other one was greater than 50. So it's cumulative. So we're just using this. It's cumulative, but it starts at 51 because it said greater than 50. So 51 up through the 80, which is, oopsie, which is 0.3718. Okay, I should get my paper on these. And wrap up this video. So those are the probabilities that we just found. So the last few try, it says, a lacrosse team is selecting a captain. The names of all the seniors are put into a hat, and the first three that are drawn will be the captains. The names are not replaced once they are drawn, because you can't have a captain being a captain, a person being a captain twice. You want to see if the captains all play the same position. State whether this is binomial or not, and state why. So it is a no, and that is because we are sampling with without replacement. So the probabilities are not staying the same. So the probability of success is not staying the same. So we cannot say this is a binomial experiment. And that wraps up lesson 4.3 and chapter 4 altogether. So catch me back for chapter 5 and 6.